Hello everyone. In this session, we will explore the different types of distributed computing models. This session is a key part of broader module on cloud computing fundamentals. In this session, we will understand the various distributed computing models, learn how much each model is structured and where is it used, compare different models like peer-to-peer, cluster, grid, and utility computing. Build a strong foundation to understand cloud computing more clearly. By the end of this session, you will be able to identify which module suits which situation in the real world. If we can quickly recall, distributed computing is where a task is split across many computers connected by a network. They all work together, share the workload, and help solve complex problems efficiently. Now, let's look at the main types of distributed computing models one by one. We have peer-to-peer computing, cluster computing, utility computing. Under utility computing, we have grid and cloud computing. Let's start with peer-to-peer computing, also called P2P. This model is like a group of friends sharing among themselves. In P2P, all computers called nodes are equal. There is no boss or central controller, there is no slave. Each one can act both as client as well as a server. You may have seen this in torrent applications like BitTorrent. Here, when you download something, you're also uploading some to others. It's a mutual give and take system. It's useful when large files are shared across many people, like movies, games, or software. Next, we have cluster computing. Imagine a team of people sitting in one room, working together on the same project with clear coordination. In this model, several independent but connected computers work as one system. They are all located in the same place, like a data center or lab, and managed by a single admin. This model is used in places where performance matters a lot, like in scientific research labs, where huge simulations are run, or weather forecasting systems. It's more centralized than P2P and offers better control and reliability. Now comes utility computing. Think of it like electricity. You don't buy the entire power plant, you only pay for what you use. Similarly, in utility computing, users pay for computing resources like storage or CPU based on their usage. This model gave rise to cloud computing. It offers flexibility and cost effectiveness. You can increase or decrease your usage based on your need and pay only for that. It is used in businesses where demand changes regularly, like online shopping during festival times. Now let's look into grid computing. Imagine universities and research centers across the world connecting their computers to work on one big project. Grid computing allows geographically distant systems to work together as a single system. They share resources, data, and computing power. It's used in fields like bioinformatics, climate research, and particle physics, where huge calculations need to be done. So, even if the computers are in different cities or countries, they are linked to form one grid of computing power. Finally, we have cloud computing, the model that combines features of utility, grid, and cluster computing. In cloud computing, resources like storage, processing, and applications are provided over the internet. You only need an internet connection and a browser. Everything else is handled remotely. Cloud systems hide complexity and allow users to focus only on using the service. They provide on demand access, high scalability, and global reach. It's the most flexible and widely used model today, suitable for businesses, governments, and even personal use. In this session, we explored major models of distributed computing, each built to handle different types of tasks. Peer to peer helps with direct sharing, Clusters provide coordinated local power, and grids allow global collaboration. Utility computing introduced the idea of usage-based billing, and cloud computing combined all these models to give us a highly flexible and scalable system. These models form the backbone of today's internet-powered services. That brings us to the end of this session. Thank you and keep learning.